design meeting to cover the RFC 25 votes. There's the HackMD. I can share it if people want, or we can just all open it. It's fine with me. And the idea was, I thought we would walk over what's in the RFC and then some of the various proposals, and kind of discuss those details and see if there are any problems, and also like what we want to do going forward in this area. I mean, more generally, like the RFC is all about custom DST, or the area I'm referring to, I guess, is custom dynamically sized types and the various extensions that have been proposed around them, of which there are many. That seemed like a good agenda. Any additions or changes to it? Okay. Does everybody have the HackMD? I will throw it in the chat. I'm going to go ahead and not share it because, I don't know, sometimes that's weird. So, okay. What's in the RFC? Simone, do you want me to talk or do you want to talk? Since it's your RFC. You know you're muted.
You're muted.
Simone? Okay.
Yeah, sorry. Zoom is being very slow as well. I'm gonna try with the wired internet.
Okay. Well, I guess we'll just wait. I'll keep going, but if Simone, since this is nothing Simone doesn't know. I mean, the core idea is that it's defining this trait, which it calls pointee. I think in the past I've proposed the name referent, which I like better, but anyway. But it's something that can be pointed at by a pointer, and it would be implemented for all types, since all types can have pointers to them, at least today. And the main thing that trait does is carry the metadata as an associated type. And the metadata has to be all these things: copy, send, sync, whatever. And so the idea is if you have an &t, it is a that pointer that is paired with a t::: metadata, which could be unit. Hey, Simone, working better?
Yes, much better. Sorry about the delay.
Okay. I was just saying that talking about the pointee type and thin,
yes,
the idea that pointee with metadata of unit.
Yeah, so the idea is that every type would implement these traits automatically. And the purpose of the trait is to have the associated type for the pointer metadata.
Yep. And then there's some functions for manipulating it, right? Like the ability to extract metadata.
So for slice, for example, we have from raw parts where it takes a data pointer on a length. And the idea is to generalize this to all pointers, possibly dynamically sized.
So for slice, we have that method, but this would add like a generic one for all, right? That just works. So there's a from raw parts for every raw pointer type.
Yes.
It takes a unit pointer and a metadata and creates, basically builds a fat pointer.
Yes, so similar to how slice have from raw part and from raw part mute, similarly for const pointers and mute pointers.
And what else can we do with this? So the other thing that's pretty relevant is the DIN metadata struct.
Right. So that's the one case, trade objects, where the metadata is not something that already exists in the time system. So we want to represent it as a type that's pointer sized and minimally doesn't do anything else except you can obtain it and from a trait objects and then recreate the white pointer from it and the data pointer. And optionally, we can have other features on this type, like accessing size of.
Yeah. And that's paired with the ability to permit, I'm just looking at this last line, which I hadn't thought that hard about. So right now, when you want to build a trait object, you have to build it from a size type. And you're saying you would change it to any thin type.
So originally, to actually create a trait object, you would unsize it from a size type, yes. And now a library would have the ability to separate the components of that white pointer and then recreate it later from separate components. So the only way to obtain a vtable pointer would be from a trait object, an existing one.
Right. Yeah, so you could use this to get metadata, to get out a vtable or DIN metadata and then put them back together.
Yep.
But going past that, so if, in my summary, I have like these two bullets at the bottom, which are basically moving from places where we have used sized to using this thin trait instead. So changing the bounds on null from sized to thin, and also changing the rules around casting to DIN values, DIN types. And
right. So the thin bound is something that now we have pointer metadata in a type system with the trait. We can express the constraints. This type is sized. This pointer is thin, even if the type is not sized. So that makes a difference for external types.
This is good for null, but it has a funny behavior for DIN. I mean, I guess it's no stranger than extern types generally, but like right now, if you have an ampersand DIN foo, for example, we can find the size and alignment dynamically. But if you had coerced it from something that is not sized, you wouldn't be able to do that, right? Like right now, the vtable encodes the size and alignment, that's what I'm trying to say. But
right.
If you go from a thin type, the main difference between a thin and a sized is that you don't know the size or alignment in the thin.
Well, you can know under certain circumstances. I mean, for C string, for example, we would know.
But I don't believe the RFC adds anything that allows.
No, it doesn't. But like in general, this doesn't apply to all thin unsized types.
Yeah, amazing.
Nico, you're talking about going from a thin type to a trait object. And
yes,
the only way to do that is for unsizing, through unsizing a type that implements a trait to DIN of that trait. That's already the case today, and that doesn't change with the RFC. And it's that unsizing operation that creates the vtable.
Yes, but the vtable can't be created is kind of my point, unless the type is sized. At least the vtable today contains.
Yeah, this RFC doesn't change anything there.
Maybe I have the wrong notes. In my notes, it says that it does. It's a minor point. I think we should move on.
Yeah.
Sorry, which part of the notes was that?
The final bullet says permit pointer casts from ampersand t to and DIN foo if t is thin plus foo. But I really sort of regret spending this much time on it, so I want to move on.
Okay.
This is a minor point. The main thing is, right, okay, so you have a trait that describes metadata and the ability to take apart and put together fat pointers using. So I guess, does anybody else have any questions about what the RFC says so far? I've been asking a lot. Okay. So what are some of the assumptions? These are some that I came up with. Things that, like, because the question is, what are we locking ourselves into, so to speak? One of them is that all metadata has to be copy along with send, sync, ord, hash, unpin, and static. That would be hard to be otherwise.
About that, someone mentioned in the RFC thread that because the raw pointers exist today and they are hash and comparable and all of that, then because they contain metadata, then the metadata should be all of that as well. And there was discussion about the bounds in the associated type definition. When implementing this, I have a branch where I implemented the pointy trait. So I copied the definition from the RFC with the constraints, and then I didn't actually implement traits for teen metadata, and it still worked out because it's a special case in the compiler. So probably I would be able to trigger some compiler errors or even internal compiler errors. But anyway, my point is the metadata type that you can extract with a public API is not literally a struct field inside raw pointers. It's only the wrapper that you get. So even if raw pointers can be compared, doesn't mean that the metadata has to implement the partially equal trait and hash trait and all of that. Maybe we want to anyway, but it's not as hard a constraint as we thought in the RFC.
I'm not sure I understand. So you're saying it may not have to because we could make some conversion into something, like when we implement hash, we could. I didn't really understand that. So
I think I understand that it's like I think someone is assuming that users cannot implement a pointee, right? Which some extension RFCs on this do propose. But if they can't, then the type that is the metadata type isn't necessarily, it's not the actual vtable necessarily, right? It's like some standard library type that is wrapped around the vtable that the compiler generates.
Yeah.
And so because of that, the fact that the vtable type doesn't implement hash doesn't mean that the pointer doesn't implement hash, because the pointer just hashes the actual address of the vtable. It doesn't.
I see. Okay.
But it would be, this is only so long as users cannot implement pointee, which is where it gets more, like, which is I think where these bounds actually matter, right? Is if we allow users to implement them.
Yeah.
So it is an assumption of this RFC that pointee trait is implemented for all types. And you don't need a bound on generic code to use it.
Right.
Yeah.
One thing that does point out is that you can't add more bounds later.
So because it's already implemented for all types, you can't have manual impulse of this trait. And how that interacts with future RFC for custom DST, where you would want the trait to be implemented manually, I don't know.
You could permit manual impulses as long as they're inherent, like as long as they're in the same crate, and we could have some special rules.
Okay.
But I think we'd have to switch things a little bit.
Obviously very special, so that would be expected. Okay.
I'm trying to understand the outcome of this.
I think given the level of interest, I think it's worth exploring that further.
Yeah, I was going to turn to some of that, but sorry, Felix, go on.
Oh, I wanted to try to just summarize the outcome of this discussion regarding, this started with a discussion about the bounds on the metadata associated type, right? And I'm trying to understand the outcome in terms of whether Simon is saying we can remove a lot of these bounds because they aren't actually necessary for the use cases under interest, or is the idea that since we can't add the bounds later, we in fact want to be conservative and add as many as possible? I'm just want to make sure I understand what decision, if any, is coming out of this.
So in RFC, the argument was because raw pointers already implement all of those traits, then the components of raw pointer must implement hash and all of that as well. And what I found is that's not the case. You can have hash for raw pointers that, like the current implementation, just transmutes the Y pointer to a tuple of view size and hashes that.
Yeah, I guess I'd be curious to know what bounds are actually needed or expected to be needed in practice and try to narrow down to just that, just to keep our options open. But I'm still trying to digest this.
So the places where those bounds are useful is generic code that manipulates metadata of any type. So that generic code probably wants the metadata to be copied because it's convenient, or at least clone. And then we can discuss whether it's useful or meaningful to compare metadata or hash it, etc.
Can we also punt on these decisions because it's not a breaking change to like enforce that they have it later because we are not allowing any custom metadata yet?
Right.
Yeah. Yeah, I think like
to add bounds, but or at least to remove them, sure. But I think we want those bounds. I mean, if you look at the impl, I think the argument in the RFC is basically correct. Like the existing impl hashes the metadata, so we do want to be able to do that. But
yeah, we can change the standard library to use transmute less and instead use the new function to access metadata.
Right, I think that's what I would assume you'd rewrite this impl to not use transmute, but instead call the metadata free function and hash that.
Yeah, and in that case, it's useful to have the bound for hash.
I guess my most immediate reaction is to this question of copy and static, about whether there's potential future scenarios, in particular with dynamic library loading, where you'd want the vtables to actually be things that aren't dynamic library loading and unloading. I know it's not something that we support today. I don't think in any real proper sense, but it doesn't mean I don't want. I still something that I think about in the back of my head. But hashing seems fine.
If I remember correctly, there's already a behavior that's arguably a bug where the same combination of type and traits can have multiple vtables if they are compiled separately. And in some sense, they are the same vtable, but the pointers will compare not equal.
Yeah, that's probably true. I think we maybe anyway, let's not get down that road. All right, well, we can, so this is a thing to investigate. Let's go look at some of the like other stuff that might come down the line and how this would be compatible or not compatible with it. I think the tick static bound is definitely interesting. That also applies to function pointers, like this whole dynamic loading thing. So it'd be nice to have function pointers with a lifetime bound, but anyway. So Ollie made a big list of proposals. We can walk through a little bit, some of which have more details below. I want to start with this first one of trait objects and multi-trait objects because it's something that I expect us to want to implement relatively soon. Or I would love it if we did. I have some notes in the section called din foo plus bar that's down below. But basically the summary of this is that according to the RFC, there is an unresolved question about this, but there's din metadata that is basically a vtable and it's a single pointer. And so that that works for all of our existing trait objects. I don't think there's any interaction with trait object upcasting in particular, but we have discussed different representations for multi-trait objects like din foo plus bar. And one of the things that they could be represented as multiple vtables. And the advantage of that would be if you have like din a plus b plus c and you want to upcast to din a plus c, you can just drop the b table basically. However, the disadvantage is that your pointer is really big. And so the advantage is that it's really easy to get all the possible like subsets that you could want. The disadvantage is your pointer is really big. And maybe it's better to, maybe we don't expect there to be really long lists of traits, and it would be better to just always have a single vtable if you have to generate like all the combinations of possible sub vtables. So the problem is if you have only a single vtable pointer and you have a plus b plus c, and you have to be ready for that to be upcast to either a plus b or b plus c or a plus c, like all the combinations, and you can't sort of know ahead of time which ones will be actually used. So you sort of have to, and you can't generate them dynamically. You kind of just have to generate them all. That's annoying.
The number of subsets is exponential.
Yes. That's no
But-
fun.
So that's not great, but if the total number is small, maybe that's not really a problem.
Right, exactly. And it's
Should
just
be
static.
common to have dozens of traits. Maybe.
Just static. Right. Yeah, you'd think it's uncommon. And if you, I don't know, right, you'd think so.
So long as it's not num traits with 17 different bounds.
It only matters which ones you actually put in the din, I guess. But yeah. Well, it'll be also for upcasting a single time. If you combine that with upcasting and you have a trait foo with like a whole bunch of super traits, then it has to be upcastable to any subset of them. It could be a lot of vtables.
So personally, I think the very big pointers are not very good, not good. So I would prefer a solution where we keep a single vtable pointer and maybe have other vtables reachable from there. But either way, if we change din metadata to be parameterized over the din trait type, then in that case, the very wide pointer should still be possible.
Yeah, so I don't know if everyone saw that. Maybe I'll add a little note about it. I'm adding into the doc above proposals and compatibility notes. People see this part of the RFC. So there was a proposed extension to, instead of having din metadata be just a simple type, it should be parameterized so that, and I guess it would be a question mark size, huh? So that you have like din metadata of din foo instead of just metadata. And that gives us the ability to change its size and representation as we wish. But the downside is you can't just talk about a vtable in the generic case anymore. You have to talk about a vtable for this din type.
And maybe that's a good thing because that means you can't mix up vtable pointers for different traits accidentally.
That you wouldn't necessarily have to indirect it.
Indirect it. I didn't understand that.
If you know exactly what type you're talking about and what its vtable is, then it's no longer necessarily a dynamically sized type.
But you don't know what type the vtable is for. You just know what trait it's.
This would be like trait generics.
Like what generics?
So we'd need a form of like trait generics. Or no, oh no, it's the object type that you can put into the.
Yeah.
Yeah. Okay. Cool.
I guess I
That's
don't
easier
know.
than adding trait generics.
Yeah. I think it would just not make sense to have like a din metadata of U32 or something. probably have to figure out what happens if you do it, but you couldn't get an instance.
I think it's a type you can name, but you can't get the value of it.
Right. The compiler will have to deal with it sometimes. It'll be annoying, but
And the alternative to having it bound on a trait is to store something like a enum, right? Instead, like we could potentially have multiple versions of dim metadata that the compiler generates and like a discriminant or something. Or is that precluded for some reason?
you could, I mean, the main thing would be that the size and alignment of dim metadata will potentially change over time, I guess. So maybe that's fine to say, this is rep or rust, you can't rely on it being a single word or something. Yeah, I don't know. I'm kind of no, this seems like a good, I think the unresolved question was the right way to handle this situation. Like we should experiment a little bit and we can worry about it when we have to stabilize. But I am kind of curious what use cases the parameterized version of dim metadata helps and which one's harder.
So actually, I was curious, the usage of dim metadata in practice with the RFC, you have to already specify that you're getting out the metadata and specify that the metadata associated type is dim metadata in order for this to be useful, right? In terms of there's no other way to actually get the metadata out and be able to manipulate it without specifying that. So it seems to me like this choice is already sort of parametric, right? In that if we decide to change the representation later, the code will stop compiling if they've committed to this, which may be bad or may be good, but it opens up this chance.
Go on, sorry. I think another thing that I forgot I wanted to say is actually we could just have dim metadata. It could be a single word, but because we don't have a type like din foo plus bar yet, we don't know what its metadata type is, right? Maybe it's not din metadata, maybe it's din metadata 2 or something.
2B. Yeah.
2B tables, I don't know.
Array of din metadata. Like,
what's that?
Array of din metadata, like.
Right.
Yep.
Oh, that's an interesting point. Yeah.
Like we have a type for things that are variadic over a number of the same type.
It would be unfortunate if at this point we're committing to that is the only possible representation for the metadata of a dynamic of multiple traits, but it certainly is an option.
Point is, we're not actually committed to very much, but yeah.
Yeah. Am I correct that the representation of the din metadata doesn't actually have to match the pointer representation? Like we could potentially have complicated logic to pull out and sort of make a user visible struct and then repack it back into the pointer.
That is true also.
Not saying like we want to, but it
this was
means
basically similar
very flexible.
Yeah.
About half. Yep.
I think users will expect it to be like a repro transparent structure on the address of the vtable. Because like we will probably there's a lot of unsafe code, so we're probably gonna need to make pretty clear guarantees about like.
So the implementation of the metadata function is basically transmute. So I would not expect that function to have a lot of logic. It could in theory, but I don't know.
So Josh asked some questions that are, I don't know if you meant those for sync or async, Josh, but I'd like to go on to talk about some of the more extensions though. The question Josh asked was basically, do these live in std and core? What traits do we guarantee that DIN metadata will have? I think the answer would be the same, but I can let Simone answer, but same as metadata, right? But it can probably grow more, unlike metadata.
And it will have inherent methods for getting the size and the line of the type.
Yeah.
I feel like the safe thing to do is to focus on DIN metadata and thin, and leave like pointy as an implementation detail in the initial, in like the MVP that is like currently unstable, to avoid having to worry about these questions around what if we want users to be able to implement pointy and what bounds do we require and so on. Like, for example, it was a bit concerning that it has to implement unpin, because unpin was obviously added long after the other traits in that list. And what if someday we want to add another trait like that, but we can't now, and so on.
Yeah, we should.
So I think the adding a new bound to the associated type is fine, because custom implementation of that trait is not allowed.
I think it's okay. I think it's okay so long as we don't allow custom implementations.
Yeah.
Right.
And we improve. There is one scenario where it could be a problem with the current rules we have around well-formedness, but actually implied bounds would change some of that. But potentially, like if you're writing generic code and you say, I have some type T that has a metadata of you, right now you have to give the right bounds to you for it to be a metadata. And so we couldn't change that set without breaking generic code. But if we implied bounds, if we, in some versions of implied bounds we talked about, and like some of the ones that Chalk implemented, that's not true. You actually get, by virtue of saying that, you get to assume that U meets all the bounds, so you can actually add more bounds without breaking people. But so there's some interaction there. Making pointy unstable to start is reasonable, I think. But
I'm not a fan of keeping the trait unstable if it's part of the signature of stable APIs like the metadata function.
it would significantly reduce the ability to write generic code.
Yeah, you would be able to be generic over. But I think it's a good point that, well, if we deal with this this example about well-formedness, then there isn't really a risk until we want to deal with people implementing their own types, like implementing special DSTs, which is definitely out of the MVP anyway. So
yeah, I'm going to add these notes up to the point where I brought this topic up about wanting further bounds. So the point is, until you have custom impls, this isn't as big a concern, except for well-formedness rules, and implied bounds might change those. Okay. So in terms of the extensions, we went over trait objects. It seems like we can jump right to implementing. The main one is implementing unsized for yourself, right? Sort of custom DST. And I don't know how much detail we'll be able to go into, but we can talk a little bit about what that would look like. There's a section on it in the HackMD that says custom DST RFC 1524 and RFC 2594. It doesn't have a lot of detail, but and then I've since looked at some other RFCs and they all kind of feel quite similar. I'm sure they're different in various ways. Where basically you can imagine that you have some struct somehow, and you can implement and specify what its metadata looks like. And that metadata has to implement various traits that the compiler can use to figure out size and alignment and that sort of thing, I guess. I don't know. Not sure what else is worth going into about it. Like, you know, I think it does work fairly smoothly. What's in this RFC? But I guess one point that comes up a lot is the exact hierarchy of how much size and alignment information you get at each point. So, but pointy is usually just none. Right, and then there's like different, sort of like an extern type. You don't get any guarantees that you can even ask what the size and alignment are, even dynamically.
I think one main question here is like how much control about that we should give to users. Like, for example, for extern types, should it be possible for some types to specify a way to compute the alignment and so on? And how do we figure out that there's no alignment to be computed? Like, how do we expose this fact that it's not possible?
Yeah, we've been around and around on this. Do we do it statically or do we panic? It's a pain. Neither is very appealing. It's the problem. But it's kind of not. This particular RFC sidesteps those problems, I think.
Yes, it was very intentional to not block on answering a bunch of questions around custom DST and sizedness.
I think it's also the thing about like C-string, where like its size would not be contained in its metadata if it worked the way it was in C.
C-string is a good thought experiment. I
Like,
mean, in the sense that it's kind of an extern. You can compute its size, but it's not obvious to me that size of val should be ON.
Yeah, that's true.
Ever. I guess I would say that extern types and custom DST, I guess Ali, you wrote this in the doc even, like extern types are kind of one extreme version of custom DST or something. Like, especially if they gain the ability to specify their own size and alignment, then they're really treading on the same ground.
Yeah.
But the main thing about custom DST is, I mean, essentially, if you allow people to write their own pointee, then you can write methods. I like the matrix example or something, right? But then you can kind of use the methods in this RFC to really do useful stuff. I don't know what exactly this would look like, but whatever. If you imagine you had a two-dimensional slice that has probably not U8, probably U size, has multiple indices. Whatever. And that's pretty cool. I don't know.
It also occurred to me that if we ever did have another thing like unpin, it just would be that it would have to be we're like wherever we currently. I think we require unpin because box implements unpin, like references implement unpin regardless of T's. bound, but that would just have to say like it would be like implements on pin where T : metadata implements on pin. Like we just have to put the bound where we're currently relying on the assumption rather than having the assumption.
But that we may not. Oh, I see. Yeah, so that works if that works for a case like unpin.
I think it works for a lot of these where like none of them are like the link. Well, definitely anything that we're going to add in the future. I think we can design where we say that this functionality only works with types whose metadata implement the new auto trait or whatever we have created that would be required.
Yeah, even something like hash seems reasonable to say, well, yeah, if you pointers are only hash if the metadata is hash and all of the existing metadata is hash, so it's backwards compatible.
But the trait solver doesn't know that.
Like it would even be backwards compatible if they like if we were adding hash to language now, even if all the existing metadata does not implement hash, then this feature just would not be usable with any existing types, which would be unfortunate, but like it wouldn't be. It's a new feature, so it's not backwards incompatible.
Yeah.
Does requiring the metadata to be unpin break any of the stunts people might wish to pull with how they efficiently store their metadata together with the pointer? For instance, if you had an aligned pointer and only 2 or 3 bits of metadata, if you wanted to store it in the low bits of the pointer, could you get away with that kind of thing?
I don't know if you can get away with that, but I don't. Unpin does not keep you from getting away with it. I think the other limitations are going to be a bigger problem, like how you're going to an actual address and stuff.
I addressed this a little bit in the procedural vtables RFC and came to the conclusion that we'll need runtime code for things like unsizing and even just accessing the base pointer because you'll need to extract the correct bits and so on. And this means like really simple operations like, well, an unsizing operation could now do arbitrary logic at runtime, which might be very, very surprising to users.
Well, I think it's...
Well, that logic may be as simple as mask out the low bits.
It might be, but people could also write like enormous code when you're just making a method call. But maybe that's not an issue. Maybe we can just allow that and ignore it.
Technically, our issue with like deref and stuff, which I think is like actually, if you wanted to do this, you probably should just use a custom struct that implements deref to your to the real type.
Yes.
Are there any other extensions worth digging into, like procedural vtables? We're kind of running out of time anyway.
No, we can ignore procedural vtables. Those are compatible with everything else.
Seem like, you know, the other ones in the list, custom, so going down the list, we had trade objects, custom wide pointer layouts. Not really sure what that is, but I think it's kind of custom DST. Custom vtable layout. That's totally orthogonal from this, since this is only saying that we have a pointer, but not what the pointer points at. Extern types we kind of covered, kind of orthogonal from this, except for the use of null. Custom metadata is the extension we just talked about. One thing I would point out in general, I think there's been some other proposals somewhere on the line that said allowing a trait to define what its vtable looks like. Or there was this stable vtable RFC, that was another one. And I think that's all, that's kind of a, either if it's just changing what the vtable looks like, it's fine. If it's even changing what the metadata of a din foo trait looks like, I don't know that we'd ever do that, but that's the sort of, we already kind of went over that with din foo plus bar. Like we have ways, plenty of ways to address this idea if we need to. All we're really committing to is that all existing din types have this din metadata that we defined. And that combining multi-trait objects and custom metadata, I think that's maybe what I just talked about, kind of, except more complicated. because there's more than one trait. All the more reason not to ever support that feature. And then there was finally Knox's RFC around pointy and din sized, which I think is just an extension of this RFC essentially to try and address statically the extern types question by adding a new default question mark bound din sized, which I think we kind of rejected the last time we talked about this, if I recall. It seemed horrible, or at least like a very likely ergonomic and confusing situation.
It's also breaking, and I think that
yeah,
Knox actually found it, like tried to implement it and found it to be breaking, like it broke the compiler immediately. So
yeah, I think adding new question mark things is very subtle. It's not just happen usually.
Yeah.
You have to pay careful attention, especially around traits. But in any case, I don't think it conflicts with this RFC. So there you have it. I guess 2 questions to leave ourselves with. I would be inclined to merge the RFC, but people can think about that. I don't want to make that decision in the meeting, or I'd be curious if anyone has any strong objections, but also how much we, how open we are to other extensions like custom DST and so forth. I am somewhat unopen. I would much rather prefer, I would encourage people to write or design note, or what was I calling it? Survey paper. And log it for the future, because it seems like a major design area that's pretty hard for us right now. But
my personal feeling is that any form of custom DST spends a lot of complexity budget for the language. And I would not be surprised if Rust never ends up with custom DST. So I try to be a good citizen with this RFC and not prevent any future proposal, but I'm not counting on them happening either.
yeah, I feel like this RFC provides a pretty good stepping stone in that it seems very obvious how a custom DST would look thanks to this RFC, right? It would just be being able to manually implement pointee. But I don't think that we will. I think the other side of it, the figuring the traits that the metadata has to implement to be allowed there, so the compiler can get size line and so on. That's where it's actually like a lot more complicated work, and that's what we don't want to take on right now.
Right. I think there is a lot more to the design of custom DST than just implementing custom implementation of these traits. And my view is that this RFC is not a new feature, but rather finishing a missing piece of existing DST.
yeah, I was just going to say that even in the absence of custom DST, I think this RFC adds a lot of value, and kind of always thought we would end up with these APIs, but somewhere along the line we never did for manipulating flat pointers.
Also, basically every RFC and the list we have in HackMD does introduce some kind of this trait, or some methods to extract the parts. So it's like everyone wants this, no matter which destination RFC we're looking at.
So Josh is raising various points in the chat that I think would be good to log, but I totally agree with them. I mean, but they're relatively minor. You agree, Josh?
Yeah, to be clear, none of these are things that make me want to reject the RFC. These are things that make me want to make sure the RFC is exactly what we want before accepting it. So, like, on balance, I think that this is good and should move forward. I want to make sure that static is a bound we want to commit to, and that the pointer type here is the correct pointer type we want to commit to, that kind of thing.
I'm logging these in the doc. I think Yeah, on the point of clone, so Felix pointed out that it'd be not, maybe it would be better to have meta be clone, but I think that is just not possible because ANT has to be copy, and ANT carries a metadata as part of it. So
doesn't have to be copy, right? Like a future just because all current metadata is copy doesn't mean that the trait itself needs to require it, right? Because like we could condition the bound on NT to require that the trait is like the metadata is copy. Then
but it's
because
super
today you
complicated.
can write generic code.
Yeah.
Today you can
Yeah,
write
they-
generic code that copies references or pointers.
Exactly. You would basically, that's kind of the same as din size. Like you would be redefining what t : size means to mean t with point t whose metadata is copied or something.
Sure.
And I don't think there's a real use. Well, I'm sure there are use cases, but for making it not copy. But well.
And same with the tick static bound. If the metadata has a lifetime parameter, that means raw pointers need to have a lifetime parameter as well. What would that look like?
That's a little subtler because you don't, starconst t is not tick static for all t. T has to be tick static, but it is, you're right that it's connected. Like I don't know if we can actually express the connection. Like we'd be able to say something like the metadata is static if, that's actually not, no way, I sort of take that back. We already have that. That's a rule we already require that if you, I think, yes. If, because of the way our well-formedness rules work, and RFC 1014 or whatever it was, if you have t : foo, if you know that t is tick static, you know that t : foo is tick static. That's just like a basic structure that the language guarantees you. And so as a result, we don't need to say the metadata is tick static in order to know that ampersand t, or sorry, that starconst t is tick static if t is tick static, because t : metadata must be tick static. That makes sense. About that.
So if I'm trying to rephrase that, because the only way you can get the metadata is by having an instance, then metadata lifetime could be tied to the instance lifetime.
No, it's not really about the instance, it's about the type. So we basically have a rule that we try to guarantee that says for any associated type t : foo, or the more generic case with more type parameters, you know that t : foo outlives the lifetime tick A if all the inputs outlive tick A. So if t outlives tick A, then t : foo must outlive tick A as well. And that's, you can sort of think of this as if you had to write an impl that specified the value of foo, you'd have to name the lifetime in that impl. You know, you have to write like impl foo for some type t, or sorry, impl trait, let's call it iterator. Impl iterator, type item. What lifetime can I actually write here? I can only write lifetimes that appear inside of t. I can't just make one up out of nothing. Or I can write tick static, but that's okay, that outlives all things. So that's why, so if I have like I could write tick A, but if I write tick A, it has to be coming from an input somewhere. And that's partly because we don't allow, like if you try to write this impl, you'll get this obscure error saying that tick A is not constrained by the input types. That's the reason we have that rule in the first place. That makes sense? Maybe you weren't seeing what I'm typing, actually, it occurs to me, since I'm not sharing my screen.
I'm trying to understand. The counterexample here, though, or the example you're giving, I don't understand. You're still talking about a Dyn iterator returning, getting the associated type off of the Dyn iterator, or right? Or not? Am I misunderstanding the connection here? Like there can still be a tick A under the hood.
No. Well, if you don't have a tick A in the input types, you can't write tick A in the associated type definition.
But okay, but you can have types that have tick A in them.
So what? So all we want to say, but that's not what we need to prove. We need to prove that star const t, where t is tick static, is also like, we need to prove that t tick static implies star. We should take this offline. Star const t is tick static, and I'm saying we can prove that to be true without this tick static bound on metadata.
Oh, okay. You're just making an argument for why we don't need the bound. Sorry. Okay, that's fine. Okay.
But okay.
What if t is not tick static?
But if t is not tick static, then this isn't. Then it's already true that star const t is not tick static, right? Like,
I mean, I can get the metadata of a pointer and then drop the pointer. The borrow checker doesn't prevent that.
Yeah, it will, actually.
Right. So Simon, are you asking, like, there are use cases you can imagine where you'd want to still then ensure the vtable thing is tick static there?
I don't know. I'm not sure.
It should prevent it. I think if you wrote some, I think you're saying, what if I have like generic code and I do like let metadata. So I really have to go, but let's take this offline, but I'll finish this example. And I write like let m equals, or it's hard to make this example make sense, but something like this, such that as a borrow that's part of this.
Yes, that's what I had in mind.
Yeah, and then you do this. This will not work because m's type will include, either we can resolve this to a specific metadata type and we know if it has tick A or not, or it's going to be something like this. And in order for that type to be valid all the way down to here, to the point where it's dropped, tick A would have to be extended down to that point, which means that the loan will cover this drop effect.
I see.
So it will work. All right. Thanks, everybody. On the basis of this meeting, I intend to move to merge. And we'll see where it goes from there.
Thank you.
Bye.
Thanks.